You hear the number and it sounds like a victory, almost heroic, the kind of milestone that should come with fireworks and triumphant music, because a machine built by human hands has traveled farther than anything we have ever made, pushing outward for nearly half a century, surviving radiation, cold, silence, and the slow death of its own power supply. And now it has reached a distance of 1 light day from Earth, which sounds enormous until you pause for a second and ask what that actually means. And this is where I want you to slow down with me, because I remember the first time I sat with that number and felt the strange sensation that something wasn't right. Like being told you climbed a mountain only to realize you're still in the parking lot. Voyager 1 launched in 1977, long before modern computers, before the internet, before most of the technologies you use every day even existed. And since then, it has been moving at about 61,000 kilometers per hour, which is absurdly fast by any human standard. Fast enough to cross continents in minutes. Fast enough that if you could drive that speed on Earth, you would circle the planet in less than an hour. And yet, after 40-plus years of uninterrupted motion, assisted by gravitational slingshots around Jupiter and Saturn, using the cleverest orbital mechanics we could design, it has traveled the cosmic equivalent of 1 day of light travel. Now here is the thing that begins to itch in my mind. Light is not slow. Light is the fastest thing allowed by the universe. And even that speed, the ultimate speed, needs an entire day just to define the distance Voyager has reached after half a century. When I picture this, I don't see a triumphant ship racing into the stars. I see something else. I see a metal object drifting just outside the front gate of a house, and everyone inside celebrating because the door has finally opened. You might think I'm exaggerating, but let me phrase it differently, because sometimes the trick is not the number, but the comparison. Imagine you start walking at top speed and never stop. You don't sleep. You don't slow down. You just keep moving for 50 years straight. And at the end, someone tells you, congratulations. You've moved 1 day's worth of distance on the scale that actually matters, and suddenly the victory begins to feel a little strange. Not because the effort wasn't extraordinary, but because the scale is merciless. I've always liked doing this sort of mental experiment, taking something that sounds impressive and pushing it until it either grows or collapses. And here the number collapses, because 1 light day is not a gateway to the stars. It is barely the thickness of the wall that surrounds us. The uncomfortable part, and I want you to feel this carefully, is that Voyager did everything right. It didn't waste fuel. It used gravity assists. It followed the best trajectory we could compute. And still, it only reached this distance, which means the problem is not engineering incompetence or outdated technology. The problem is the size of space itself. You can almost sense the mismatch between human intuition and cosmic reality, like bringing a ruler to measure the ocean and realizing you haven't even touched the water yet. And I find that both fascinating and unsettling, because it forces me to rethink all the casual ways we talk about going to the stars, as if they were cities on a map instead of distant fires separated by emptiness so vast that motion itself starts to lose meaning. Voyager 1 is not really racing anywhere. It is drifting outward slowly, patiently, almost stubbornly, and the farther it goes, the more it reveals not how powerful we are, but how small our reach actually is. And when I sit with that image, a tiny machine traveling for half a century just to achieve 1 light day, I don't feel triumph or despair. I feel something quieter, like the moment you realize the horizon isn't getting closer no matter how long you walk. The real problem, I think, begins with a word, and it's a deceptively friendly one, because we say light year with the same casual tone we use for kilometer or mile. And when you hear that astronomers discovered a planet 100 light years away, something in your mind quietly assumes that this is just a long trip. Difficult perhaps, but still a trip. Something you could imagine crossing if only you had a faster engine, a better ship, a bit more patience. And I want you to notice how sneaky that is, because the word itself contains year, and your brain immediately associates it with time, with duration, with something that can pass, something you can endure. But a light year is not time at all. It is distance, and not just any distance. It is a distance so absurdly large that our intuition stops working and quietly replaces reality with something more comfortable. 1 light year is about 4 trillion kilometers. And that number sounds impressive until you try to hold it in your head, at which point it dissolves into abstraction. Because the human brain is not designed to grasp trillions. We barely manage thousands. Millions already feel vague. And beyond that, we start thinking symbolically rather than physically, which means we stop imagining and start labeling, and the moment that happens, we lose our sense of scale. So I like to cheat a little and shrink the universe down to something you can picture, because once you do that, the illusion collapses almost immediately. Imagine Earth as a tennis ball sitting in your living room, not metaphorically, really sitting there, textured, yellow, small enough to hold in your hand, and now the moon becomes a marble placed about 2.5 meters away, which means you could stand up, take a few steps, and travel from Earth to the moon. Already that feels manageable, even cozy, and then the sun becomes a large sphere, nearly 1 kilometer away, far enough that you wouldn't see it clearly from your window, but still something within the same city. And this is where things start to break, because now you ask where Voyager 1 is on this scale, our most distant ambassador, our farthest reach after nearly 50 years. And the answer is disappointing. It would be just a few kilometers from the tennis ball, maybe in the next neighborhood, still wandering around the outskirts, still clearly part of the same local environment. And then comes the question that always changes the mood. Where is the nearest star, Proxima Centauri, in this model where Earth fits in your palm? And the answer is so strange that it feels like a mistake, because it would be about 260,000 kilometers away. Not across the country, not across the continent, but almost the real distance to the actual moon. Which means that if your tennis ball Earth were in New York, the nearest star would not be in California. It would be floating somewhere near the real moon, separated by an enormous ciel, empty gulf where nothing meaningful exists, no stepping stones, no clouds to hide behind, no halfway points, just vacuum, radiation, and a few stray atoms drifting in darkness. And suddenly the phrase 1 light year stops sounding like a journey and starts sounding like a barrier, because you realize we are not talking about traveling between cities. We are talking about crossing an ocean so large that even light, the fastest messenger in the universe, needs years just to traverse it. I remember the first time I tried to picture this honestly. Not symbolically, but spatially. And I noticed something subtle happening. My mind kept shrinking the gap automatically, like it didn't want to accept the emptiness, as if intuition itself were rebelling against the scale. And that resistance told me more than the numbers did, because it revealed that our language is constantly softening reality for us, turning walls into roads, distances into durations, isolation into adventure. And when you strip that away, when you look at a light year as pure distance instead of a poetic unit, it stops being a measure and starts feeling like a stretch of nothing, so vast that even imagination hesitates before stepping into it. Once you accept the scale, the next step is almost uncomfortable in its simplicity, because all we have to do is basic arithmetic, nothing exotic, nothing speculative. Just take the speed of something real and extend it forward in time. And I find that strangely more disturbing than any science fiction scenario, because there is nowhere to hide behind imagination. Voyager 1 is moving at about 61,000 kilometers per hour, which is already extraordinary, faster than anything humans regularly build, and it has been traveling continuously for decades. So you might think that over long enough time it would begin to cover meaningful interstellar distances. But this is where the math quietly pulls the floor out from under that intuition. Voyager took roughly 48 years to travel one light day, and a year contains 365 days, which means that to travel one light year at the same speed, you simply multiply those numbers, and suddenly you arrive at something around 17,500 years. And I want you to pause there, because this is the moment when travel stops being travel and becomes geology. 17,500 years is not a mission duration. It is a slice of human prehistory. It is longer than recorded civilization, longer than agriculture, longer than cities, longer than anything we casually associate with continuity. And that changes the meaning of the journey entirely. Imagine launching a spacecraft at the end of the last ice age, when mammoths still walked across northern plains, when humans were painting animals on cave walls and shaping stone tools, and that spacecraft moving steadily, never failing, never stopping, crossing one light year today, arriving not at a destination but merely at a milestone in empty space, and the people who launched it long gone, their languages extinct, their cultures erased, their descendants unaware the launch ever happened. At that point, the idea of exploration starts to dissolve, because exploration assumes a continuity between departure and arrival, some thread of intention connecting the two, but here the thread snaps under the weight of time. I sometimes think about how long human institutions actually last. Empires rise and collapse in a few centuries. Languages drift into incomprehensibility in a millennium. Even religions transform beyond recognition over thousands of years. And now we are talking about a single leg of a journey requiring 17 millennia, which means the entire context of the mission evaporates before the ship even approaches anything interesting. And remember, that is just one light year, while the nearest star system is more than 4 light years away, which means you take that already absurd number and multiply it again. And the result stretches beyond 70,000 years, a span that begins to overlap with the entire lifetime of our species as we currently recognize it. What fascinates me here is not just that the journey is long, but that the length fundamentally changes the category of the problem, because engineering assumes machines that operate within human timescales, maintenance cycle, design lifetimes, material degradation. All of that becomes meaningless when the clock runs for tens of thousands of years, and suddenly the spacecraft is less like a vehicle and more like a fossil moving through space, a relic drifting slowly between stars. The math itself is trivial, almost embarrassingly simple, and yet the conclusion it produces feels disproportionate, as if something so elementary shouldn't lead to such a profound limitation. And that contrast sticks with me, because it means the barrier is not technological ignorance or lack of ambition. It is the quiet multiplication of large numbers, and when you follow them honestly, you discover that even our fastest machines stretch across time, not like arrows, but like shadows. So you might think that all of this sounds dramatic only because we are talking about empty space, about distances without a target, and that everything changes once we aim at something real. something tangible, the nearest star, a neighbor rather than a vague direction. And I understand that instinct because the mind relaxes when there is a destination, as if naming the place somehow makes it closer. But this is exactly where the illusion collapses completely, because the nearest star system, Alpha Centauri, is not a symbolic step away. It sits about 2 light years from Earth, which sounds modest until you remember what 1 light year already meant in cold arithmetic. If a single light year requires roughly 17,500 years at Voyager-like speeds, then the distance to Alpha Centauri stretches that to around 70,000 years. And this is not a dramatic estimate, not pessimism, just multiplication again. The same quiet math applied to a real target, 70,000 years, is such a strange span that I find myself reaching for anchors just to keep it meaningful, because otherwise it floats beyond comprehension. 70,000 years ago, humans were still spreading across continents, adapting to new climates, learning to survive ice and drought. And everything we call civilization, cities, writing, science, industry has happened in only a small fraction of that interval, which means a one-way trip to the nearest star would last longer than almost everything we have ever built or remembered. At that point, the idea of exploration begins to lose its familiar shape, because exploration usually implies departure, travel, arrival, and communication, a loop of experience shared with those who remain behind. But when the travel time alone exceeds the lifespan of civilizations, the loop breaks, and what remains is more like a message thrown into the future without an audience. I sometimes try to imagine the spacecraft itself not as a sleek vessel racing toward another sun, but as something slowly aging, its materials exposed to micrometeoroids, radiation, and the slow accumulation of tiny failures, drifting through darkness for tens of millennia. And even if nothing catastrophic happens, even if it remains intact, by the time it reaches Alpha Centauri, it would be less a visitor and more an artifact, something that arrives long after its creators have vanished. And if you place humans aboard that journey, the problem transforms again, because now you are not only transporting mass across distance, you are transporting meaning across time, and meaning decays faster than metal. A crew leaving Earth today would not arrive themselves. Their distant descendants might, if everything went perfectly, but those descendants would live in a world so detached from the original mission that the destination becomes abstract, almost mythical, like traveling toward a legend whose origin no one remembers. There is also a subtler realization hidden here, which is that Alpha Centauri is not some exotic or distant prize. It is literally the closest possible star, the easiest interstellar target available to us, the minimum challenge the universe offers. And yet even that minimum stretches beyond practical reach, which suggests something deeper than a technological gap. It suggests a mismatch between human-scale ambition and cosmic-scale separation. I find that oddly humbling, because it turns the familiar narrative of exploration on its head. Instead of a frontier waiting just beyond our current tools, we see a frontier that remains distant even under idealized persistence. And the nearest star stops looking like the first step outward and begins to resemble a lighthouse seen across an ocean so wide that sailing toward it becomes indistinguishable from drifting. When people first confront these time scales, they reach for what seems like an elegant solution, and I admit I used to find it elegant too. The idea of a generation ship, a self-contained world traveling slowly between stars, where the original crew departs, knowing they will never arrive, but their children will, and their children's children after them, until one distant generation steps onto another world and completes the journey. And on paper it feels almost poetic, like planting a seed whose fruit you will never taste. But the moment I try to imagine it as a real human situation rather than a diagram, something starts to unravel, because you are no longer solving a propulsion problem. You are trying to freeze, meaning across tens of thousands of years, and meaning is far more fragile than machinery. Imagine locking 5,000 people inside a closed metal environment, not for a mission lasting years or decades, but for 70,000 years, which is not just longer than any human institution. It is longer than most of what we call history, and immediately the ship stops looking like a vehicle and starts looking like a civilization, with politics, disagreements, boredom, ambition, fear, and the slow drift of culture. Even on Earth, with open skies and endless land, empires rarely last more than a few centuries before, transforming into something unrecognizable. Languages mutate until speakers of the original form can no longer understand them. Values shift. Myths replace facts. And all of this happens while people can walk away, migrate, rebuild, reinvent themselves. But inside a sealed ship there is no outside. No frontier. No escape valve for social pressure. After a few generations, the mission itself becomes abstract, like a story told by ancestors. And stories change. They simplify. They exaggerate. They turn into legend. And eventually someone asks a practical question. Why are we doing this? Why maintain this trajectory? Why preserve resources for a destination no one has seen? And suddenly the ship is no longer a mission but a debate. I sometimes think about how quickly perspective shifts when environment defines reality. Because if you are born inside that ship, the corridors are not temporary. They are the universe. The artificial sky is the only sky, you know? And the idea of Earth becomes as distant as a mythic homeland, something you learn about in fragments. Maybe even something contested, doubted, reinterpreted over thousands of years. Biology itself begins to drift. Small genetic changes accumulate. Radiation introduces mutations. Isolation reshapes physiology. And the descendants of the original crew might gradually adapt to artificial gravity, recycled air, confined spaces, becoming suited to a world that no longer resembles the planet they left behind. Meanwhile, the ship's systems demand constant maintenance. Life support cannot fail even once. And that requires knowledge passed faithfully across hundreds of generations without interruption, without cultural collapse, without conflict destroying critical infrastructure, which feels less like engineering and more like hoping a fragile chain remains unbroken for longer than recorded human experience. And even if everything somehow works, if by some statistical miracle the ship arrives intact near another star after 70,000 years, the people stepping out would not be explorers completing a mission. They would be inhabitants of a closed ecosystem, suddenly confronting a universe they never expected to see. Their journey, no longer a purposeful voyage, but a slow transformation that consumed its own origin. Like a message copied so many times, the original handwriting disappears, leaving only a faint trace that something once began with intention. At this point, the natural reaction is to say all of this pessimism depends on slow technology, that Voyager is a relic of the 1970s, and we should not judge the future by the limitations of the past. And I sympathize with that instinct because physics has surprised us before. Engines improved, airplanes crossed oceans, rockets left Earth, and it feels reasonable to assume that one more leap could shrink the stars into reach. So let's be extremely generous and imagine something almost outrageous. A spacecraft capable of traveling at 10% of the speed of light, which is about 108 million kilometers per hour, a velocity so extreme that ordinary intuition collapses again, because at that speed even a grain of dust carries enormous kinetic energy, like a microscopic bullet, and a collision with something the size of a pebble would release energy comparable to a large explosive. So already we are assuming materials, shielding, and engineering that border on speculative. But suppose we solve all of that. Suppose we build the impossible machine and accelerate it successfully. Now the math changes dramatically, because at 10% of light speed, 1 light year takes roughly 10 years to cross, which sounds almost manageable compared to 17,000. And suddenly the journey to Alpha Centauri becomes about 42 years, which feels like the duration of a career, not a geological era. And for a moment the idea of interstellar travel begins to look plausible again. But then the details start creeping in, because travel time is not just cruising. You must accelerate, decelerate, navigate, explore. And if you want to return, repeat the entire process. And now the mission stretches toward 90 or 100 years, which is not abstract anymore. It is a human life. I try to imagine being on that ship, leaving Earth at 20 years old, watching everything familiar shrink into memory, spending decades inside a moving world, knowing that the people you left behind will age and disappear while you are still in transit, arriving at another star when you are already old, looking out at alien planets, not as a young explorer, but as someone nearing the end of life, and then deciding whether to turn around, knowing the return journey mirrors the first. And suddenly even this heroic speed does not feel like freedom. It feels like a commitment so total that it consumes the entire arc of existence, and this is for the nearest star, the absolute minimum challenge, because if you extend the same reasoning to more interesting targets, like systems, dozens of light years away, the numbers inflate again. 40 light years becomes 400 years at 10% light speed, which returns us to generational timescales, not because the engines are slow, but because space itself stretches faster than our improvements. There is also the quiet issue of energy, which tends to hide behind the velocity, because accelerating any significant mass to a fraction of light speed requires enormous kinetic energy. And when you estimate it even roughly, you find that launching a single large spacecraft at 10% of light speed would demand energy comparable to the total production of humanity over long periods. Meaning the mission is not just technically difficult, but economically and physically monumental. Something closer to reorganizing civilization around propulsion rather than building a vehicle. What fascinates me is how the dream survives until the very end of the calculation and then gently fades, not through catastrophe, but through accumulation. Years adding to decades, decades to lifetimes, lifetimes to centuries, until the idea of casually visiting another star dissolves into something closer to exile, a journey where speed no longer feels like motion, but like a long, irreversible commitment to distance. There is another detail that quietly reshapes everything, and it comes from something we rarely picture when we talk about leaving the solar system, because we tend to imagine a clean boundary, like crossing an ocean and finally stepping onto another continent. But the solar system does not end where planets stop. It fades gradually into a vast spherical halo of icy debris known as the Oort cloud, a region so enormous that its outer edge may extend nearly a light year from the sun, which means that the territory gravitationally tied to our star is already comparable to the distance between stars themselves. When I first tried to visualize this, I realized that even if Voyager has technically left the heliosphere, the bubble of solar wind, it has not really left home in any meaningful gravitational sense. It is still wandering inside the sun's extended domain, like someone who walks past the city limits but remains inside the country. At its current speed, Voyager will take centuries just to reach the inner regions of the Oort cloud and tens of thousands of years to cross it, which means that for the next 30,000 years or so, our most distant spacecraft will still be moving through the outskirts of our own system, not yet in truly independent interstellar space. And that changes the emotional picture completely, because instead of imagining humanity stretching toward the stars, you begin to see us inching slowly across our own front yard. I find something humbling in that realization, because it strips away the idea that we have already begun interstellar travel, replacing it with something quieter, more tentative, like testing the depth of water with a toe. And when you combine that with the distances between stars, the question that inevitably appears is the one people often phrase simply, where is everybody? If the Milky Way contains billions of stars and perhaps many civilizations, why is the sky silent? Why no visitors, no signals, no evidence of cosmic traffic? And one possible answer emerges naturally from the numbers we have been staring at. Maybe everyone is trapped the same way we are, separated by distances that convert communication into centuries and travel into epochs. Imagine civilizations scattered thousands of light years apart, each one building telescopes, detecting faint signatures of others, perhaps even recognizing that intelligent life exists elsewhere, yet unable to reach them, unable to exchange anything more than slow, fragile signals, and even those signals stretched across time so long that the sender may vanish before the reply returns. In that picture, the galaxy is not a network, but a collection of isolated islands, each illuminated by its own brief flare of intelligence, aware of others, yet permanently separated, like candles burning in a vast dark hall. Visible, but intouchable. I sometimes think about how different this is from the stories we tell ourselves where space is a highway connecting worlds, when in reality it behaves more like an insulator, damping interaction, stretching separation, turning neighbors into abstractions. And this leads to a conclusion that feels both sobering and strangely clarifying, because if interstellar escape is so difficult, if even our fastest probes barely leave the sun's extended reach, then the idea that humanity can simply abandon Earth and relocate elsewhere begins to look less like a plan and more like a comforting myth. The distances are not just large, they are protective in a way, locking us into the environment that produced us, making our planet not a temporary launch pad, but a rare and irreplaceable habitat. And when I sit with that thought, the stars above stop feeling like destinations and start resembling distant lanterns, suspended in a cathedral ceiling. Beautiful, inspiring, but forever beyond reach, while everything that matters remains quietly contained within the fragile sphere we already inhabit.